ZombieTech. Welcome to ZombieTech, a forum for engineers, scientists, and inventors to ponder on the technologies needed to survive the inevitable zombie apocalypse.
She's Addie.
He's Whisker.
And today we have one of the original people that helped us get where we are, Chris Savage.
Yay!
Yay! Yay for Chris.
Now, for those of you who don't know who Chris Savage is, which is probably not that many of you at this point, Chris works with Parallax as one of their engineers, and they make a lot of the stuff that we use on our show. So we're very happy that we know Chris, but we actually know Chris because we spend every single day hanging out with him and his crew over in Savage Circuits IRC.
Mm-hmm. And if
you guys are the Savage Circuits IRC channel.
And if you guys haven't joined us, well, you're missing out on just a think tank of awesome. So
besides the IRC, there's also a massive forum there with lots of activity where people post projects and ask questions and get help from one another. And that can be about Parallax stuff. It can be about any electronics sorts of projects or just fun geekery. Mm-hmm. There's also support on the site for blogs and all sorts of other stuff.
Yep.
I like that phrase, fun geekery.
Yeah, I think you could even do stuff like post your own music on there if you wanted to.
Oh, yeah. Yep.
Yeah,
Cool.
It's a pretty fleshed out content management system that's basically Chris spends a lot of his free time managing.
Mm-hmm. So, Chris, what have you been working on? Projects to come. Where are we at with all that?
Well, it doesn't seem like I've got a lot done lately, but the website had to be updated for security reasons, so I updated that, and of course, like Windows, the updates broke a whole bunch of things, and spent a considerable time fixing them. But in the process of fixing them, I got my lists of things that I was going to post out and crossed off the stuff I'd done, reorganized the stuff I plan on doing, and I remembered holidays are coming up, so I actually have a list of projects for like Halloween and stuff, things that I meant to do last year and didn't get done, but I have all the stuff. Like my wife bought these plastic pumpkins that are they're hollow. They have a light bulb inside. You plug them into the wall. You turn the little switch on the cord, and it just lights up the inside of the pumpkin. Mm-hmm. We meant to hack them and do something else with them, and we actually did hack one for our oldest son's Halloween costume. Parallax, he works there too, and Parallax Halloween costume competition, and he went as the Headless Horseman. So the Headless Horseman's head is a pumpkin, so I fitted it with an automotive taillight assembly inside behind a shroud, and it pulses, flickers like a candle. So It kind of looks like there's a candle inside. And then I pre-programmed it with several sounds from the Headless Horseman from a video game, saying various things, that he could push a button and have it say these things.
And did you use a propeller for that?
No, actually, I just had to pulse width modulate randomly the light, so I just used a super carrier board with a basic stamp, and I used a FET to drive the 12-volt lamp and seal lead acid battery inside.
Gotcha.
iPod for the sounds.
Oh, that works.
So
cool. So in your organization, what major projects do you have that you'd like to work on? Or have worked on? I mean, I know you've done a lot of stuff for Nuts and Bolts, and
you actually have a Nuts and Bolts article coming up that I just have one little bug in the code I'm trying to work out, and the guy that is helping me on that's from a different country, so I don't always talk to him as often as I'd like to. But once it's done, I actually am going to be putting that, submitting that to Nuts and Bolts. It's kind of it's based on one of the app notes that I did for Parallax, where it demonstrates PC communication to the propeller using Visual Basic, like VB.net. Mm-hmm. So the idea is that you have this application you're going to do for Visual Basic, but you don't really want to bog yourself down with dealing with the communication between the application and the propeller. So there's a background task that runs in the propeller and handles the communication. So it runs in another cog. And then there's also like this example form for how you can implement in your application controls and like say LEDs and things like that, so that when you send a command to turn an LED on the propeller, it actually sends it sets the variable, sends it down to the propeller gets it, updates it, sends back an acknowledgement optionally, and then the form updates to say, oh yeah, you sent this command to turn this LED on, and it turned on.
Yeah, we've been doing a lot of that here lately with the tracker program written in Visual Basic that is sending over serial commands to a propeller running said cog off in a different cog.
Yeah.
Yeah, this one's it is direct control, something like what you're doing, but it's more or less, at least on the propeller side, it's meant to be a background thing. Obviously on the Visual Basic side, it's sort of a foreground thing, but the end application might be something where you just want to be able to access some propeller controlled project that you have somewhere in your house and from your PC.
Gotcha.
So it
Yeah.
could be over wireless. It could be anything.
Sounds like a fairly general purpose useful tool to have available for it.
Yeah, the protocol is really simplistic. It just sends back and forth 16-byte packets. 16 bytes in, 16 bytes out, just constantly at like 115K.
I chose to go for a 2-byte protocol. One of the bytes says which register value we're dealing with, and the other one says what to set it to. Mine, you can't do the reading, so you'd have to add a 3rd byte to say whether or not I want to read or do I want to write it.
Yeah, I haven't even put in any kind of like checksum or anything like that yet. There is a header. There's a 3-byte header that's set an exclamation point and a VB from the Visual Basic side. And then there's a P1, I think, exclamation P1 is sent from the propeller so that each side knows when it gets the start of the packet instead of landing in the middle of it.
I tell you what, I love designing communications protocols. I know that's about the nerdiest thing anybody could possibly say in a sentence, but I love making communications protocols.
Actually, I'm with you. I mean, really, in the end, it should have a protocol, because if the it's only 16 bytes plus the 3 preamble bytes, but if anything were to get corrupted, especially if you do it wirelessly, then you don't know what you're sending to your controller.
So let's see. This week, we've just come out of 2 episodes where people were very much focused on Open Hardware Summit and on the Maker Faire. I know Parallax sent someone over to Maker Faire. But this week, I think we can carry on some of what we were talking about just last week with Jeremy Blum, because he does a lot of video tutorial work on YouTube, as do we, and you do as well.
Mm-hmm. Yep, Savage Circuits TV.
Now, I know there hasn't been too many episodes lately as you've been getting moved over and getting things ready to start back up production again. But I know everybody is really excited to see what you're going to be coming out with this season.
Yeah, it's amazing. I thought I would get in here, and I had a plan to get everything set up and be back in business within a month. And there's stuff that I was supposed to have done the first month we were here that I just got done this weekend.
Moving is always such a complicated and longer and harder process than you think it's going to be.
Mm-hmm.
Well, I overestimated my ability to get everything done, that's for sure.
Well, that's okay. You do what you got to do. So, are you by any chance on the team for the Prop 2?
Nope. The propeller stuff is all done by R&D, and that's really just Chip, Bo, and Jeff Martin.
Oh, okay. So no secret tidbits.
No, that's why it's when we had Chip come on to the at the time we didn't have the IRC channel, we just had an inline chat thing on the website. We had him come in to try to answer some questions. Of course, a lot has changed, and unfortunately, the most up-to-date information is really in the Parallax forums right now.
And what's can you tell us a little bit about that for people who don't frequent the Parallax forums?
The latest thing I think that Chip was working on that I know of, because he's pretty much secluded. He's like me. He likes to just be, away from everybody so he can work. He doesn't want to really have to have any distractions. And so the last thing he showed me, which was still a long time ago, but it may or may not be new information to some, is the IO pad design, because the current propeller is capable of doing some pretty interesting things. And of course, each cog has two counter timer modules, which can access any of the IO pins, and then they can generate video, and there's a PLL in there, which there's some really neat stuff. But the propeller 2 has got so much more. The pins are capable of so much more, so many more functions built in. Direct AD, DA even. You can change the thresholds of the pins. There's some pretty neat stuff he's doing with them.
Cool.
Yeah, I've looked into some of it. I've talked to several people in the community and got little bits and pieces here of what it's going to be able to do. And wow, is it going to be miles above what the Arduino crowd is able to do, which I like. Anything that allows me to do hacks that blow those guys out of the water just always makes me, happy.
Apples and oranges, guys. Apples and oranges.
Yeah, I made a post about that because I've been asked many times, hey, Chris, what's your opinion on the Arduino? You never talk about the Arduino on Savage Circuits. Anybody who wants to come on and talk about the Arduino is more than welcome. Before Parallax, I worked with many processor platforms, only a couple microcontrollers, but many, like the 6502 was my first CPU that I programmed. And in the last 10 years I did stuff before I got into microcontrollers. It was Z80. I mean, I was probably like the main PR guy for Zilog for the Z80. It was like, to me, the best chip ever made for the hobbyist. But things come and go, and I moved on and eventually had to port stuff over to something smaller and simpler and cheaper.
Sure. Cheap is good.
But yeah, so I started elsewhere, and I certainly have no. And I actually work with Atmel chips a little bit too. I haven't done it very much because I have so many propeller projects that are behind that. They're the priority. But I actually have a couple of Atmel projects.
And what are those?
One is a little RGB LED module. It's this little tiny square board. It's about 1 inch square, and it has 3-pin headers sticking out of each side of it. And what it is basically is you can connect them together. You can daisy chain them with servo connection cables like parallax cells. And you can send serially. Basically, you send, I think it's 4 bytes. I haven't played with these in a while. You're basically sending an ID because each one of these units can be programmed to have a different ID on the bus from 0 to 255, followed by 3 bytes, which are from 0 to 255, which are the R, G, and B values. And the RGB LED on there turns that color and remains that way until it receives a new command or until power's turned off.
Cool.
So
let's see. Brainwagon was working on what I think amounts to a Z80 emulator from scratch. I believe it's the same processor. He gave the actual processor number though. Do you remember the number on it?
Well, when I worked with the Z80, there was the Z80A and the Z80B, and I think the Z80H was a 6 megahertz version that was out, but that's around the time that I kind of moved on and started porting stuff over.
He was working on getting an old copy of BASIC to run on his emulator so that he could compile, other programs using that as sort of a stepping stone. Pretty fun stuff.
A lot of people had Z80s and didn't even realize it back in the CPM days. They were very popular for CPM machines, along with the 8080. But yeah, the Z80 got me really interested in hardware interfacing because it was so easy to use, compared to the 6502. And it had like the 6502 had index registers, but the Z80 had index registers, and you could stack registers. You could refer to a register as a single byte, or you could refer to a register pair as a 16-byte value or 16-bit value, and that was really powerful stuff.
I think that knowing these old processors is very important to being in a position where if anything really bad happens, like, your neighbor tries to eat your brain, and, all the chip fabs go down, this kind of technology is something that's much easier to build back up to.
Mm-hmm.
So if you want to, like, be able to build the machinery to, say, create your own sheet router, and civilization is down, it's a lot easier to go out there and rip an 8080 out of some old piece of kit you pull out of the junkyard and get that up and running than it is to, say, try to get a modern Intel processor running.
Oh, definitely.
There's not nearly as much as that you would have to, build around that chip to actually get it up and running. I think that knowing these and knowing how this older technology works is a very useful thing to keep around. So when you hear people get excited about doing hobby projects that still use these old chips, I think it's just a wonderful thing.
Yeah, some people take it for granted. I mean, those old chips like the Z80 were just so simple to use, and even though there were a lot more parts involved because it's a processor, not a microcontroller, you still have to hang RAM off from it and ROM and IO and things like that. The actual architecture was so simple, and it was all just straight plus 5 volts. You didn't have to have any special power supply or anything, no special clock. You can run a TTL clock into it. The Z80 started executing instructions at memory address 0 instead of at the top of memory looking for some jump vector or where to go. So you just, started your RAM off in lower memory, and it was just really simple. And the neat thing about that kind of technology, and the thing that attracted me to it way back then, is unlike microcontrollers where when you buy one, it has X amount of ROM, X amount of RAM, certain IO, might have some timers, might have some PWM, but you have no control over where that stuff is, what addresses it occupies, how much you have. When you buy it, it's pre-configured. Mm-hmm. When you use those old processors, you build it the way you want it. So
modular systems.
Yeah, you can tack your memory onto it as long as you don't run out of address space due to it being an 8-bit processor.
Well, that was the neat thing, too. Some people, I didn't do this, but I saw quite a few pioneers at the time doing it. You had 16 bits of address space, 64K. I built my system simple to have a 32K EEPROM. Well, actually, 32K EEPROM, old school back there, UV eraser, and a 32K static RAM in the upper memory. But there were some people who actually banked their memory so that they used like a latch to switch in and out other chips.
Yeah, that's a nice hack. I like that.
Mm-hmm. Yeah, and it's just basically you'd use a couple of the upper address lines to switch in and out the entire rest of the memory map.
And now at bringing it forward here, as of today, Addie was just working on writing her first propeller program.
It's true.
As we were waiting for Chris to get around here so we could record the show, she was getting LEDs to blink on and off on the demo board.
I was gnawing on it, and it was
the relation to what I was saying with the propeller is Chip said when I first met him and he showed me the propeller before it came out, he made the propeller to get back to the 6502 and the Z80, to get back to the freedom that we had back then, the freedom the programmer had, or the designer, to use this chip and do whatever they wanted with it and not be constrained by the architecture or closed operating systems or closed libraries and things like that.
So was that the concept behind the cogs?
No, the cog thing was just like jumping to 32 bits. It was just, why settle for anything left? Everything seemed to be going backwards. I went from using 16-bit CPUs to using 8-bit microcontrollers. It seemed like I was going backward in technology. And then on top of that, PICs. The thing that took me to Parallax in the basic stamp is I looked at PICs because everybody said, "Oh, use PICs. You can convert all your stuff over to PIC." I looked at a PIC and I said, "It's got interleaved RAM and banked memory. Why would I want to monkey around with that stuff?" But the propeller chip's actual original kind of marketing strategy was kind of freeing the designer, freeing the developer, and not closing the door on what's under the hood and how the thing works. And that's how it was. That's how the old 6502 and the Z80 and the 6809, 68,000, all that stuff was.
And Eddie very quickly got that idea today when she realized that with a single line there, she can control something that's hardware attached to the thing with a wire.
Blinky LEDs.
And, just because it has the RAM on there, there's nothing stopping you from, creating a circuit to attach to external RAM if you were interested in doing that.
As far as blinking and LED goes, it's highly underrated. I mean, that is a very simple way of getting feedback from something without having to hook up a complicated video monitor or LCD to try to get some kind of feedback.
Yeah. I often use that 8-bit 8 bits of LEDs that are built onto the propeller demo board as an 8-bit number that I can just print to as a debug in my programs.
Exactly. People think about, first thing I'm going to do is hello world. Well, yeah, but most projects that use microcontrollers, well, nowadays it's going the other direction because we have more multimedia type stuff. But most originally, things that use microcontrollers didn't really necessarily need any kind of display. They had simple input-output functions, and there was no need for an LCD or a video screen on simple microcontroller-based stuff. So LEDs were your indicator, your heartbeat, if you will.
Mm-hmm, mm-hmm.
I was using the Parallax LCD module that you donated to the show, and with this little serial communication to it, and it's really easy to use.
Yeah, the serial displays are, though I do have to admit, I do miss the parallel stuff. You lose more IO lines to it, but I just like the ability to write as fast to the display as the display was capable of being written to. And you're kind of constrained when you're shifting stuff serially because you have to convert it to a serial stream, and then the LCD has to convert it back to parallel.
Mm-hmm.
Now, the Parallax displays use the 8-bit mode at least, but many of the serial displays, LCD displays, use 4-bit mode, so every operation is done in 2 nibbles.
It didn't take me too long to figure out how to hack it so that I could give it custom characters and use those custom characters to draw things on it that weren't necessarily intended. It was a fun learning experience. I'd never played with one before, and I thought, hey, that's really useful.
Yeah, my 2 most common custom characters are the degree symbol on the Parallax ones because that's not available, and the various 1, 2, 3, 4, or 5 segment bars to make a bar graph.
Cool. Well, so where do you think then that the future of, with the Prop 2 coming out, where do you think the future of Prop 1 is going to be?
Well, it's still going to be a simpler architecture, so a lot of people are still going to want to start off with that. I mean, just because something more powerful comes out doesn't mean you necessarily jump to it. Mm-hmm. The people who right now who are veterans of the propeller and who want more, especially those people who are doing video applications and stuff, they're just chomping at the bit, so to speak, to get to it.
Sure.
But those people like yourself who are trying to just right now blinking LED, let's just get the basics down. Mm-hmm. There's not going to be any need to just jump right over to the propeller 2, and besides, you'll have a better appreciation for what's on it once you really learn the architecture of the Propeller 1.
Right. And what are people currently using it for? I mean, I know we've got some robots. But like, are there industrial uses? Because I'm
Yes,
completely new
there's
to this. So
some of them I think Parallax has listed on the website, although it is sometimes a little difficult to find some things. There are a couple of people, I think most of it's in the UK, or definitely it's another country. There's somebody who's using them for like I saw an application that was counting at very high speed, mind you. I think they're ping pong balls that just
oh,
go into a bin, and then they come out and they go down. They get merged together into a single line, and then there's something that's counting how many go into a bin. Then it stops them from dumping into the bin, so that you can move the next box over, and
that's
whole
cool.
automated thing. There's a some kind of a conveyor system with a printer I've seen posted.
Mm-hmm.
There's some, basically a lot of it's high speed counting stuff, and it's also being used where they need a display where you might use a single board computer and a VGA monitor. Well, you still can use your VGA monitor, but now you don't need a whole several $100 single board computer and then have to buy an IO board for it to hook to your industrial system. Now the propeller connects directly to that and directly generates the VGA video. And you can plug a PS2 keyboard and mouse right into it, and you've got the same thing as your SBC for, a lot less.
Right.
Yeah, and it's not nearly as sensitive to EMF problems as a more complicated full computer system would be, even if it were an embedded system. There's so
That's
much
true.
less going on with the prop. It's a lot easier to harden it against that kind of stuff.
And it's low power, and it doesn't get hot. I mean, I've worked with even basic stamps like the BS2PX are running close to 126 degrees. I think it's 50 megahertz that thing's running at, or 32. The propeller, even at 80 megahertz, is really cool to the touch. It's almost like it's not even on.
That's cool.
One thing that we're going to be using it for here in the near future is a motorized robotic jib that's going to be controlling a camera that's flying around our new studio. And I think the prop is just perfect for that kind of application, because I need to be doing pulse width modulation to control DC motors and servo control. And it's very well suited for that kind of thing.
Oscar, I've been listening to the show via iTunes, and I heard you guys talking about the quadcopter thing, and because they're becoming so popular. And that's another thing. Ken Gracie right now, and him and Matt Gilliland are spearheading this.
Oh, I think I heard about this, yeah.
Yeah, there's a whole. I'm sure by now they've come up with a name. I haven't seen what it is yet, but there's a thread on the Parallax forums to come up with a name for the Parallax quadcopter. And that is a perfect application for the propeller, because you've got a device that needs to control 4 rotors at the same time, keep itself stable. It has to monitor multiple sensors, collate all this data. And that's not even counting trying to figure out where you're going. Like if you use GPS navigation or something to say, go from these coordinates to these coordinates. That's the kind of use that the propeller should be really boasting right there.
Yeah, well, once people wrap their heads around the idea that unlike a system based around interrupts, you're literally able to do 8 things at the same time, and then you start applying it to problems that require parallel solutions. And a quadcopter is an excellent example of something where you got to be doing a lot at the same time.
Mm-hmm. Yep, and a lot of people who are using functions of the propeller and using them in a parallel processing fashion don't even realize it. Like when you use the full duplex serial object and several other ones, they launch off another cog, so they're happening simultaneously. But you could do the same thing on any processor with an interrupt. But what really shows off the propeller is when it can do all those, monitor all those sensors and control those rotors in real time. That's where, especially like robotic arms or something, where the arm doesn't have to just move on one axis at a time, but multiple axes.
Yeah, and that's exactly what we're going to be doing with that jib. It's got to control and move all of those. Let's see, it's got the jib has to be turned left and right. It's got to be flown up and down. There is a left or right on the camera, a pan, and there's a tilt. There is a servo for the zoom. There's a servo for the focus. And what you can do with a prop, and what I plan on doing, is I've got it at position 1. You punch in position 2, and it'll figure out how fast each one of those motors needs to be spinning through each part of the move so that they all start up, they all get up to speed at the appropriate rates for that thing, they go at their constant speed, and they slow down, but they all get to the position that they're aiming for simultaneously. And to do that, you can time slice back and forth between them. But isn't it just so much easier to say, okay, you, Mr. Cog, are handling this motor, you, Mr. Cog, are handling this one. Or, there's some objects out there that make it pretty easy where you've got a pulse width object on the prop that runs in one cog that can deal with, I think, 8 motors by itself.
Yeah, that's the kind of thinking I haven't seen too much of out there. There's a lot of people doing robotics and things with the propeller, but they're still thinking, single processor thinking. They're not taking advantage of what they have.
So what kind of project do you think would tax propeller out?
I think the quadcopter thing is one that really could show off its capabilities. I don't think it would tax it. Mm-hmm. Another thing that people don't necessarily think about, but they should, is a lot of cars these days, almost everything in the car is computer controlled. And it used to be that the onboard ACM module was in control of very little of the engine functionality. And of course, if you had ABS brakes, there's some stuff happening there. But I mean, my car, for example, just about everything in it is digital. Mm-hmm. And I think a propeller could run that entire car.
Wow.
So one propeller. I'm sure right now there's multiple subsystems in it for each individual section. There's probably a separate little computer chip for the engine, and there's probably one for the ABS brakes, because that's what I've seen in previous technology. But just one propeller could do all of that.
So forget the high-speed ping pong ball counting. I mean, if you could use it, make a car's control system.
Well, I think the attraction of the ping pong ball counting thing was the fact that it was able to do that and monitor sensors for the feed bins and control them simultaneously. But the main thing was it was directly generating the video, and you were able to plug a keyboard and mouse right into it. Mm-hmm, mm-hmm. So I think the multimedia thing, I think, is what was the attraction there in that particular application. But in industrial control, especially with conveyor systems, there's a lot of concurrent things happening, and ladder logic is typically what's used to define what happens and when. But just like with the camera motors and stuff, you could program each cog to just do its thing and know, but its rule set of what it has to do, and it could do it independently. Everything could be working concurrently, and just with a basic rule set, not conflict with each other. Like the whole multi-axis arm thing. I saw one person, and they have a YouTube video, and I'm gonna have to find it posted on the website. The arm. And I think Steve Norris has done this too. The idea was to move the arm from one position to another, and he shows how normally you could do this one axis at a time and get from point A to point B and move the arm. But if you try to just move it in one continuous motion, it actually has a tendency to bump into something else that's in the way of it. I forget what it is. Something in the base or. So it has to know that that's there, what position it's in, and know how to navigate around that. Mm-hmm. But it's up to each individual axis to move, as Whisker was saying, to know how to get from point A to point B within the time frame it needs to move, and just do its function. And that's what a lot of people aren't doing, but that's what the propeller is capable of doing.
I like to try to explain it as you're tracing an arc through multi-dimensional space, rather than just dealing with X and Y, or in the case of a motor, you're just, you've only got one dimension. You're combining each one of those motor's positions into a multi-dimensional place in some theoretical space. And when you trace an arc in that theoretical space, you can get them all to move in step with each other, and fortunately, the jib doesn't have to worry about running into things, because just the way it's a crane, so it doesn't have anything in the way. But you can do the same idea, but on one of those axes in the multi-dimensional space, it knows that there's an obstacle when you combine these things, and you can create an object avoidance into the pattern that it has to make to go around it. And it's just so fun what you can do when you stop thinking of it in that linear single processor doing this step, then this step, then this step. You can completely cut the ties to that stringent way of looking at it and allow it to do it more like a human body would do it.
Mm-hmm. Well, the propeller also has, each cog has its own independent memory. So if you have its own independent RAM, so if you're running PASM assembly code, basically machine code in each cog, which is the way I prefer to do things, then all of that runs within the RAM of the cog. And then there's a shared 32K of hub RAM that all of them have access to. So my preferred way of doing things with multiple cogs is to dump a bunch of data into an array, and each cog knows where in that array to get its data. And it just constantly goes there to look and see, is there something new for me to do? I'm pulse width modulating at this frequency right now. Is there a new frequency yet? Is there a new period that I can go read off from this, array element and start doing that?
A lot of people get a little bit intimidated with multi-threaded kinds of parallel solutions to problems because their experience tends to be on the PC, where when you're dealing with multi-threaded code, you get a lot of difficult problems that you have to solve when accessing shared memory. And they don't really understand that the guys at Parallax really did a good job at solving that problem on the propeller.
Mm-hmm. Yeah, you don't really have to think about it. In fact, that was one of the biggest barriers to some people when we released the propeller. There wasn't a lot of information, so we kind of really told people that, hey, this is more for people who are familiar with microcontrollers and have some understanding, maybe a high school or college entry level understanding. But now that there's a lot of base information and examples, it's perfect for even beginners, because you don't have to worry about all that. The fact that there's 8 cogs, you don't have to worry about how does it handle multiple things at once, or how do you launch stuff into the other cogs. If you're not doing that stuff, you can treat it just like any other microcontroller.
And our buddy Martin Hodge has sent us over a sample of his propeller ASC, which is based around the pin headout for Arduinos. So any of the Arduino shields will plug right into it. And I think that's a great thing, because so much of the community is Arduino centered because of the design of that header and the fact that it makes it compatible with all of these open source boards that you can get a hold of. And people like to share stuff like that back and forth. And the propeller is very easy to approach because spin is so easy to pick up.
Mm-hmm.
But it can do so much more than those chips can that are on the Arduinos. Now, I'm not saying that they're not useful. They are.
Apples and oranges, folks.
Like Addie said, it's apples and oranges. If you want to do something that requires you to do one step at a time, it's fine. If you want to do a quadcopter that has to do 100 things at the same time, but you want to be able to plug in standard shields that you can pick up, it's a nice solution.
Standardization.
Mm-hmm.
Yeah.
Now, if we could just get everybody to outgrow the old, concept of everything has to support C, so that they could free themselves from programming constraints. Spin was designed for a reason. And it has all the best elements of many languages and gets rid of a lot of the worst elements of them. But it's also necessary for a high-level language to support that type of environment, that type of hardware architecture. And some languages just weren't really written to do that.
Yeah, when you're picking up spin, you can go at it one of two different ways. You can approach it from the I wish I were coding in C, this doesn't make any sense to me sort of route, or you can take it from the starting at the beginning and looking at exactly how the propeller works in hardware. And if you go from that direction, when you get through the pasm and up to the spin, which is really just there to be glue, and it's very good at being glue, but it's also very perfectly designed for the hardware that it's running on. And that's what I like about it. It makes sense to me, not because I like how the language is laid out, but because I took the time to understand the hardware before I wrote my first program. The language makes perfect sense to me because it was written for that hardware.
Yeah, in this case, the language wasn't ported from some other hardware platform to this one. It was written for that type of architecture.
So you can take C and you can try to shoehorn it in, and I'm sure there's lots and lots of folks out there that just simply don't want to learn yet another programming language. And, that's fine. They've got C compilers for the prop. But I like working in Spin.
Yeah, that's, this is my own opinion, not Parallax's opinion, but I think that that's the big attraction of the Arduinos is the C language. So some people don't really care how much the propeller can do and all the things it can do, all the possibilities, just because they don't want to have to learn another language. And that's... And the reason, like I said, I went out of my way to mention that that's my opinion is because there's a laziness aspect there. So, because, some people don't want to learn new things, and I completely understand that. It was so hard for me to walk away from the Z80. But there's a point, like Windows 98, I still know people who use that. They do not want anything to do with Windows 7. They're not even using XP yet. They're so innately tied to what they have, and they don't want to give it up, that they'll fight tooth and nail to keep it. But there's just a point where you have to move on.
Now, like we mentioned earlier, Addie started doing Spin today. What do you think so far, Addie? You just right out of the gate.
Well, okay, so I am from the school of thought where I have never, ever had the slightest interest in programming whatsoever. Like most of the stuff you guys are talking about are completely over my head, so I can only attribute it to the zombie apocalypse, and do what I can with that. But so anyway, I opened the propeller manual today because Whisker said I should read the first 2 chapters, and get a better idea of the hardware and such. And as soon as my eyes hit the pin-ins and pin-outs, it just blinked. And it just spun. And I don't mean that in a punny way, but take it as you will.
Spin.
But that being said, when we actually started to code something, like I went to the tutorial part where I looked at the examples, and I didn't really understand it because they were explaining a lot of things that I didn't care about yet, that I don't care about yet, I guess. And so finally I just put it to the side. Wasted some time, on Twitter and whatever, and Whisker's like, okay, you want some blinkies to come on, blinky LEDs? I'm like, yes. And he's like, okay, you see that window? I'm like, oh, that window. That actually has a function, in the propeller tool. Mm-hmm. And, so he just, made me write a few lines, and I was like, oh, it works. And then from there, I guess with any programming language, once you get the language down, the how they what's the word?
The syntax?
Yeah, I guess so. Mm-hmm. The syntax of how the flow goes and all that. Once you figure that out, it's kind of, I don't want to say easy because I've only made LEDs blink on and off, but it starts getting to be where you can change it and make it
definitely
do
helps just to know the actual architecture of what you're programming helps, or at least the basics of it. Then the syntax, then kind of the flow of the language, because Spin is very dependent on indentation. Things have to be indented properly for program flow.
Yeah, as soon as I explained to her that she had to indent a line in a repeat loop, I could just see it click. She was like, oh, I get it. The farther it is in, the more it's nested. Yeah, makes sense.
But you know that the funny thing is that experienced programmers like myself have been doing that for years, just for clarity. It helps to see when you're doing a lot of things in a loop, and then there's kind of sub things happening in the loop. You indent those over to help you see what's happening and where things are at within the loop, conditionals, etc. And so spin doing that just reinforces that that's actually a good programming habit. But I was going to say, Eddie, you have an advantage here because you didn't start learning on some other microcontroller platform, so you don't have to kind of, I want to say unlearn everything else, but you don't have to change the way that you look at things. You don't have to go, oh, I just learned how to program the basic stamp, and now I'm looking at the propeller. It seems to be easier for people to learn the propeller if it's the first thing that they've done, or if they're experienced.
Well, so then my question also is, does this make it more difficult for me to learn other platforms? Because say I get used to this cog awesomeness, like if I say wanted to try out Arduino, because, a whole bunch of people are doing Arduino, is that going to make it like hell for me to learn?
I would say it would make it easier because comparatively speaking, the propeller is more complex than pretty much any other microcontroller out there. So once you have that figured out, once you have the architecture figured out and you've learned spin, then other high-level languages should just make sense because, again, spin is a culmination of the elements of other languages, including elements of C. And so if you start programming an Arduino, you'll see kind of the idea of not so much structures, but there are elements that you'll see commonalities between the two languages.
Mm-hmm.
And at the end of the day, there's only a couple of schools of computer languages, and spin falls into one of the schools that almost all of them fall into. It's it's related to so many different languages. It's you're not going to be able to jump over to something like Lisp because that's like a completely different way of looking at things. But you could jump over to BASIC, you could jump over to C or Java or any of these kinds of things.
Spin is kind of a BASIC, really. I mean, the definition of BASIC, what the acronym stands for, a lot of high-level languages that just use keywords like Spin does really fall into the whole BASIC category.
Mm-hmm. Gotcha. So, yeah. We were coding for maybe 20 minutes before you came on, and so I had a little taste of what I could start doing, and so that was exciting, admittedly. And I don't know, hopefully, I think we've been talking about potentially doing like prop tutorials from the complete noob's perspective, i.e. me.
Mm-hmm.
Yeah, some of our listeners have requested that we start up a second podcast that just goes along as Addie figures out how to do stuff with a propeller.
Right. Because there's a lot of information out there for those who already know how to program, already know something about programming languages and all that, and there's, I don't know, complicated and long-winded tutorials, like written tutorials for those who have never started, but I've tried and have failed many, many times to go into those.
That's a good thing, though, because as a co-host of this show, you bring something to the table that Whisker can't possibly bring. And I'm going to compare you to one of my coworkers at Parallax. The editor, the person who edits all the documentation for the Parallax stuff, her name is Stephanie, and she's been at Parallax for a long time. And one of the things that that we depend on her for is, as you've seen from the propeller manual, it's really not a beginner's manual.
Right.
It's a reference manual. If you want beginner, the basic stamp, like the What's a Microcontroller kit, those things break it down into really starter beginner level type stuff. This just kind of gives you the overview of the architecture and the language. It's like I said, it's more like a reference manual. But we rely on Stephanie because she doesn't know any of this stuff either. When we give her a manual for something, she doesn't have a clue. So she represents the customer who's going to get this, who potentially is going to read this documentation and be like, what the heck are they talking about? So I've submitted documentation to her before and gotten it back with a bunch of questions that I've taken for granted that, hey, yeah, I think everybody should know this. And then she says, well, how? If I'm reading this, how would I know this?
Right.
And she's right. You don't. You have to. She gives a perspective to things that we couldn't possibly have as engineers. And so, in a sense, you're to Toymaker Television what she is to our documentation at Parallax. You're that kind of fresh, new perspective on things. So you don't have the experience we do. You have the interest, just like she does. Mm-hmm. But when you look at it, you have to look at it with new eyes.
Now, have you ever done any work in PR? Because I like this fresh, new perspective spin that's being put on it versus noob. I appreciate that.
Well, Parallax has kind of trained me to be everything is about I don't say it's all about marketing, but the thing is even when you're doing tech support, mm-hmm. you're not really trying to like sell somebody something. They already have it. They need help with it. But the big thing that people come to Parallax for is we have superior tech support.
Right.
And one of the big things about that is not just, you pick up the phone and you call and I'm having this problem. Have you tried this? Mm-hmm. It's the whole. It's selling it, so to speak. It's how you interact with the customer and how you approach them and get to know them and find out what's their real problem. I've had people call and they think that their problem is one thing and it's not even related.
Yeah. Yep.
Now, before we get out of time here, I know that Addie has been looking forward to doing something that she likes to do in all of these episodes, and that's to grill the guest on a few topics here. Now, I'm going to let her go ahead and do this now.
Right, because this is, after all, ZombieTech, mm-hmm. and so we have to talk about the zombie apocalypse.
Okay.
So, top 3 tools that you would bring to the zombie apocalypse bunker.
Well, digital multimeter is probably the most basic tool that I always have with me, always have on my bench.
Okay.
Always carry with me. And I'm more tool oriented. I just have a lot of tools. I would probably just have a field kit, and that I don't think it would really break down to 3 things. I think it would be that field kit of tools. And then, of course, a reference manual. I've got, well, okay, and I thought about this since one of your last episodes, too, because I have a book called The Art of Electronics, which I've brought up before.
Oh, that's a good one.
But I got thinking about it. That's really not the reference book I look to. I go to that book when things get beyond, when things get into theory that I realize that I don't, and actually listening to Brainwagon and a few other people, mm-hmm. John S., mm-hmm. I've realized sometimes that I know how stuff works from a basic standpoint enough to get me by as an engineer. But unlike like Jerry Ellsworth and stuff, I don't think about the underlying theory of things. Mm-hmm. And sometimes those things are really important to particular concepts, especially when you guys start getting into the analog realm with your amplifiers and stuff.
Right.
Sometimes that stuff is really important, and that's when I go to that book. But I have another book that I would take with me, the Pocket PC Ref.
I don't know what that is. What is it?
I gotta look. It's still packed, actually. I have this little pocket reference guide. It literally fits in your pocket. It has tons of formulas and charts and pinouts and just everything that a technician would want to have on them. So you were talking about stripping, like, if there's a zombie apocalypse, going into a junkyard, stripping some old XT computer for its 8080 chip. Mm-hmm. This guide tells you the pinouts and the port pinouts on the PC and the pinouts of the cables for the keyboard and mouse and all that kind of stuff. ASCII charts, hex, decimal, octal translations, all that kind of stuff.
Yeah, you can't Google it in the zombie apocalypse.
Exactly. See, and that's the thing. I have become so dependent on, and I was thinking about this since your last podcast. I was thinking, I knew you were going to ask me this question, and I kept thinking to myself, well, it's kind of funny because every time somebody asks me a question I don't know, I just type it into Google.
Yeah. You
will not have that ability when the lights go out.
Yeah.
So
you heard it here, folks. If you have technical manuals, don't throw them out. Keep them around.
Zombie apocalypse.
Now, we may not use them every day anymore, but it's very important to keep them.
Well, it's always when you need them.
On
right?
our show recently, I have used Commodore 64 manuals extensively. Mm-hmm. And you can find that stuff on Google, but there's something wonderful about being able to pull a manual off of a shelf, page through, you know where the pages are, you get them dog-eared, you've used it 100 times. There's something wonderful about that.
Yep. Okay.
In the Commodore 64 manual, and it's especially the Programmer's Reference Guide, were examples of very well-written resources.
I agree.
So we have the
multimeter toolbox.
Oh, toolbox.
The general
my field
kit.
Yep.
Yeah.
Okay.
And my two favorite reference manuals. Yes.
Gotcha. Okay. Let's see. I guess that would be one of your books that you would take then, because I was going to ask what 3 books would you find useful.
I don't think I really have a third one. I have a whole shelf of books here. I'd like to throw some props to Matt Gilliland and say that his 2 circuit cookbooks that he did were really good. If I were anybody else, I would take those. But all the circuits in there are stuff that I already know all that stuff.
Oh.
So I just keep them around just for they're good resources again.
And you should probably bring some science fiction to read too, because it could get boring in the bunker.
And I would have to say it would be The Ice People by Rene Barjavel. Just considering the whole point of what you're in the first place.
Mm-hmm. Okay, so then, how would you... No, that's the wrong way to start this. What would be the coolest mode of transportation for you to get to the zombie apocalypse bunker?
Definitely a dirt bike.
Dirt bike?
Mm-hmm.
All right. And I think all your stuff could fit on it, too.
I was going to say just a field kit, some base. You really want to travel light.
Okay.
And a dirt bike could hold pretty much most of what you need to carry.
Okay. And then the first system, because you're kind of our hardware and electronics guy, right? So, what would be the first system that you would set up in the bunker?
Security.
Okay. Do you have ideas on how you would do that?
It is a zombie apocalypse. I mean, you're obviously worried about them coming in and trying to bite you.
Yeah.
Well, I was going to say, let's also stop to consider my perspective on the zombie apocalypse. I think if there is such a thing,
yeah,
I'm more of the I'm not the Dawn of the Dead type of zombie believer. I'm more of the 28 days later type of thing. I'm talking fast moving. I'm talking just people like you or I who are simply infected
and running around trying to eat you.
Well, I definitely with definitely homicidal. I don't want them near me.
Yeah.
Okay.
So given that, security would be my first.
So what kind of building would you go for then, if security is prime?
Definitely a brick building.
Brick.
Mm-hmm.
Okay.
Stone, not nothing that can be burned down. It's brick or metal.
Things always end up burning when they're not supposed to.
The old industrial buildings.
Yep.
Those things stand forever. There's some that have been around for 100 years, and that's the first place you go.
I like the idea of one of those old missile silos.
Yes, that actually would be perfect. They're selling off some of those as underground condos now.
Yeah, they're away from cities.
Remodeling them.
They're easy to heat. They're easy to cool because they're underground. Easy to defend because, well, that's what they were designed for.
All right, rich folks out there, buy up those zombie apocalypse silos in the name of ZombieTech, and we will be sure to give you a tax write-off receipt.
If you want to check out Chris's stuff, it's SavageCircuits.com. He's Savage Circuits on Twitter.
Yep.
And I believe Savage Circuits TV on YouTube.
I think it's just Savage Circuits.
Just Savage Circuits.
Yep.
You got it all across the board.
Excellent. Easy to remember.
Yep.
So thank you, Mr. Chris Savage, for joining us today.
Indeed.
Yeah, thank you for having me on.
It's highly enjoyable. We didn't really intend for it to be a commercial for the prop, but it's something that we use all the time. We use it on our show, and Chris works with them, and he's designed several of the boards that we use here and that you guys have seen on our weekly YouTube show. So I think many people here are interested in why we like it, even if they're not necessarily going to go and change what they're using at the time. I think they're okay with hearing why we think it's great.
And ADDIE programming is a laughable issue, so
Oh, everybody starts somewhere.
I suppose so.
Anything that can get ADDIE programming is a good thing.
Oh gosh, sounds like a bribing.
So I think that wraps it up for this week's show.
Okay. We'll see you guys next week.
Bye.
Bye.
Bye.